And if you took the quiz today and you wanted to see any of the work completed and kind of get explanations, we didn't do this in live math, so I figured I would work through this, and if you want to watch it and go through it, you're welcome to. So number 1 says, fill in the blank with correct answer to the word problem. Ms. Dimely wants to put 72 succulent plants in pots. She has 8 pots and wants the same number of plants in each pot. So if she has 8 pots, I'm really trying to figure out 72 divided by 8. Now, if I want to think about using my multiplication facts to help me, I know that 8 times 9 equals 72. But if I want to use just a drawing, that will help me as well. So if I have the 8 pots, I'm going to put 1 mark in each pot until I get to 72. The trick here is to stay organized. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. You can see that's not very efficient, but it got me there. And now I can count how many are in each pot. 5, I use my tallies, 5, 6, 7, 8, 9. So that checks out. So I'm going to answer 9. Woo! And it's one of the choices. Next. Now, look at this chart below. Are all the numbers in the chart correct? If all are correct, then answer true. If all are not correct, answer false. So let's take a look. If I have my counters, and then I'm just going to put E groups for equal groups, and number, I use the number sign, in each group. Okay, I'm just abbreviating a little bit for my notes. So if I have 15 counters and I have 3 groups, are there 5 in each group? Here's my 3 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, that one checks. But I have to make sure both of them check out. This is kind of a 2-part. So if I have 32 counters and 8 equal groups, will I have 3 in each group? So I'm going to make 1, 2, 3, 4, 5, 6, 7, 8 groups. Now, will I have 3 in each group? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. But I'm supposed to have 32 counters. So that one doesn't work. The first row worked, it was true, but all are not correct, so I have to answer false. All right. Similar problem, all right? I'm going to leave my column headings the same. So if I have 16 counters, 4 equal groups, and 4 in each group. 16, 4, and 4. I have 4 equal groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That one checks out. All right, the next row of numbers. 27 counters, 9 equal groups. Well, I have 3 in each group. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've got my 9 groups. So will there be 3 in each? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That one checks. I have 27 counters, 9 equal groups, 3 in each. Now I know I'm drawing it out and it's taking a long time. So you may be thinking, but Mrs. Finley, 27 divided by 9 is 3. That checks. That's another way to do it. You might say, oh, well, 9 times 3 is 27. That checks. So you have multiple ways to check your work and to check if it's accurate or not. Let's do the last one because they all have to be true for this to be true. So 24 counters, 2 equal groups, 12 in each group. Well, I can just know if I have 12 here and 12 here, that adds up to 24. Check. So yes, it's all 3 rows are true. All right, here we go. Now, this is about Ms. Gullens, and you can see we're using a bar model. This is the bar model, and it's going to match the problem. So we're going to use the bar model to help us solve this division problem. Ms. Gullens has 44 new graphic novels to put away. She has a bookcase with 4 shelves. There we go, 4 shelves. And I guess we'll just leave the top as a shelf. 1, 2, 3, 4. Okay. How many graphic novels will fit on each shelf if she wants the same number of books on each shelf? So I'm given 44 divided by 4 equals, I can even, since it's multiple choice, just see, right? I could kind of check. If this was 10, 10, 10, 10, I'd be close, 10, 20, 30, 40. But she has 44 books. So what if this was 11 on each shelf? 11, 22, 33, 44. And how could she have 48 on each shelf? That would be crazy. That would be that you added 44 plus 4. And that would not be showing that you understood the question. So, but sometimes those mistakes happen. So read carefully. All right, here we go. We're going to look at this picture. And we need to write a division equation to match the picture. Now, I want to count how many are in each circle. I see there are 3 groups, so I will need a number 3 somewhere in my equation. 1, 2. I'm going to start like it's 12 o'clock because I can already tell I started getting confused. So I'm going to pretend this is 12 o'clock and I'm going to go around the clock face in a circle. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 dots there. 1, 2, 3, 4, 5, 6, 7, 8. 8 dots there. 1, 2, 3, 4, 5, 6, 7, 8 dots there. So I know I've got the numbers 3 and 8. And if I add those up, I know 3 times 8, I can count those. 3 times 8 is 24. But it asks for a division problem. Division equation. So division, especially 3rd grade, we're starting with the biggest number first. Right? That's our whole. We have 24 dots. We're going to break them into 3 groups and equal 8. Could I also break 24 into groups of 8 and get 3? Will both work? Let's see. Both worked because I think you could do it either way, right? It kind of depends on how you thought about it. So, sorry, I moved ahead on there. So both of these will work and you can answer both. Sorry, I did not make that clear in the directions that you could answer more than one answer. All right, here we go. This says, which pattern of repeated subtraction correctly matches the division equation 18 divided by 6 equals 3. So it says repeated subtraction, so I know it can't be 1. There's no repetition there. The second bubble is addition. So I have to look between here and between here. Okay? So is 18 divided by 6 equals 3? Is it going to be 18 minus 3 equals 15? And then to that 15 minus 3 equals 12. Take that 12 minus 3 equals 9. The 9 minus 3. Yes, I'm trying to remember back to my math book. And I can remember that that is what it was showing me. When I was looking at that repeated subtraction lesson, which was on lesson 5, I remember. And it's okay when you guys are practicing if you need to go back and look. But this was 12 minus 2 equals 10. 10 minus 2 equals 8. 8 minus 2 equals 6. 6 minus 2. So this pattern is shown in this bubble. The bottom bubble is just 18 minus 3 is 15. 18 minus 3 equals 12, which isn't true. So it has to be this bubble. Now, looking at our number line, write both possible division equations that match the number line. All right, I know that on the number line, the biggest number is 15. So I'm going to have 15 divided by for both of my equations, right? So I'm going to need 15 divided by something equals something, or 15 divided by something else equals something. So I can either do 15 divided into jumps of 3, right, equals 1, 2, 3, 4, 5 jumps. Or I can do 15 divided into 5 jumps equals jumps of 3. Okay, I hope that made sense. I know sometimes this doesn't format so well, so you have the 15 on the wrong line. So I'm sorry if that was confusing. Here we go. Does the division equation 28 divided by 7 equals 3 match the image of repeated subtraction? Is yes is true, no is false. So is this showing 28 divided by 7 equals 3? Well, 28 divided by 7 is not 3. This is showing 28 divided into chunks of 7 equals 1, 2, 3, 4. So it's showing 28 divided by 7 equals 4. That's what that is showing. So really 28 divided by 7 equals 4 because 7 times 4 equals 28. Right? All right. Oh. Upon submission, you will not be able to change your answers. Are you ready to submit? Yes. All right. Hopefully that helped you and you felt good. And we will see you for more practice with math tomorrow.